Alright, when it comes to decimals, we need to realize that decimals are really just a special type of fraction that adheres to the properties of our number system. A fraction, the distance between 0 and 1, can be subdivided into any number of segments. However, if the number of segments that distance between 0 and 1 is being subdivided into is a multiple of 10, then it adheres to our place value system, and we can write it without having to actually write the fact that it's over 10. When we think about our place value system, we remember that it goes up by multiples of 10. 1 times 10 is 10, times 10, times 10, and so on and so on. And given the inverse relationship of division to multiplication, if we start here and work backwards, we realize that this divided by 10 is 10,000. 10,000 divided by 10 is 1,000. 1,000 divided by 10 is 100. 100 divided by 10 is 10. 10 divided by 10 is 1. And this is where place value comes in. If we continue this trend of dividing by 10 each time, then the next place value, which we put a decimal in between to represent that we're now talking about fractions, from 1 to 1 over 10, we're now actually saying, okay, well, this is just 1 divided by 10. So these are each segments that have a length of 1/10, or the distance between 1 and 0 divided by 10. So if we had, some number, let's say 1.3, then we mean 1, right? And we mean 3/10, which would also just be the same thing as saying 1 and 3/10. These two things are equivalent. They're the same. Instead of having to write 3/10, though, we just kind of extend the same properties of our number system. And this makes algorithms of addition and subtraction pretty easy instead of having to be constantly changing denominators to get equivalent segment sizes. If we take 1/10 and divide it by 10, well, what does that come out to be? If we have 1/10 divided by 10, remember we multiply these, we just did this in the division problem, and we get 1/100th, right? If we take each tenth and break that up into 10 segments, we now have 100 segments between 0 and 1. So if we look at this number, the 4 is in the tens place. So we have 10 segments that each have a length, we have 4 segments that each have a length of 10. And we have 7 segments that each have a length of 1 on the number line. And we have 3 segments that each have a length of 1/10. And we have 9 segments that each have a length of 1/100th. Now, since decimal fractions, as I'm going to say, follow suit with sort of the way that our number system works, all the algorithms for adding and subtracting still work with decimals just fine. For example, let's start by just talking about converting fractions to decimals, actually. Sorry, we're going to go over converting real quickly. 1/2, well, that's not a multiple of 10, is it? But is there some number we can multiply by 5 to make 10? Is there some number we can multiply by 2 to make 10? And we say, hey, yeah, I can multiply 5, 2, keep giving away the answer, I can multiply 2 by 5, and that's 10. So if I have one group of 5 over 2 groups of 5, I have 5 over 10. So 1/2 is the same thing as 0.5, or 5 over 10. 4 is a little bit trickier, so let's go to the next page and talk about that. For if we have 4 as the denominator, and we can use our long division algorithm to figure this out, but we know that 4 times 2 is 8, and 4 times 3 is 12. So there's no number that there's no multiple of 4 that equals 10. So the next place, place value is the hundredths. So is there some number I can multiply 4 by to get 100? And hopefully you recognize that it's 25, but we can kind of go through this the long way and say, okay, 1 over 4, that's the same thing as saying 1 divided by 4, so let's take 1 and divide it into 4 parts. Well, that's not going to work, so let's go over to our tenths place, right? We cannot make a group of 4 out of 4 ones out of 1 1. But can we make a group of 4 tenths out of 10? Well, yeah, we can make 2. So we've now accounted for 2 of the, we've now accounted for 2 groups of 4 out of these 10, which is 8, right? So there are 2 tenths remaining, and we can't make another group of 4. But could we make a group of 4 out of 20 hundredths? Well, yeah, absolutely, we can make 5. So our answer becomes 0.25. 3 over 8, the same thing applies. You say, okay, well, if 3 is being divided into 8, well, clearly, we can't make a group of 8 from 3 ones, because this is in the ones place. But we say, well, what if we made it 30 tenths, right? If we took each one of those ones and divided it into 10 segments, then we would have 30 tenths. And then, yeah, we can make 3 groups, right? And if we make 3 groups of 8, then we're going to have accounted for or grouped 24 of those tenths. But there's still 6 tenths floating around saying, group me, but we can't. So we say, well, what if we divide each one of these by 10? Now we're going to have 60 hundredths. And we say, okay, well, what is 7 times 8? That's 56. So yeah, I can do 7, right? And there's 56 of those 60 hundredths that came from here, right? That I've now grouped. But there's still 4 hundredths left, so I'm going to divide by 10 again and have 40 thousandths. And I say, can I make groups of 8 out of 40 thousandths? Well, yeah, how many? I can make 5. And actually, I make exactly 5. There's no remainder, so I'm done. So I say that 3 over 8 is 0.375, which is the same thing as 3 tenths, 7 hundredths, 3 tenths, and 7 hundredths, and 5 thousandths, right? I'm just expanding this. And we can go ahead and convert a few other things if you wanted to. So now, what I was just doing a second ago, we can kind of realize that the ability to expand these numbers is kind of seamless. I'm actually going to change this to say 23.45 just to really bring the point home. If I asked you to expand 23, you'd say, oh, well, that's easy, Mr. York. That's 20 and 3. Well, now, what about the 0.45? Well, we just keep going. This was 2 tens. This was 3 ones. This is 4 tenths, right? And this is 5 hundredths. And that is this number written in expanded form. Now, we can add and subtract just fine, right? This is 3 hundredths and 5 hundredths. How many hundredths total do I have? Well, I have 8 hundredths. And this is 1 tenth, and this is 4 tenths. So how many tenths total when I add these up? Well, I have 5 tenths, right? And this is 4 ones and 2 ones. That's going to be 6 ones. Fabulous. 6.58. And just like adding, this is nothing different, nothing strange here. The concept of carrying applies too. I say, okay, well, I've got 5 hundredths here and no hundredths here. So I've got 5 hundredths in my answer when I'm adding these. And I say, okay, I've got 7 tenths and 5 tenths. That's 12 tenths. Interesting. Well, I can't put a 12 in the tenths place. But I might recognize that 12 tenths is the same thing as 1, right? And 2 tenths. So I'm gonna put a 2 here, right? There's those 2 tenths. And then I'm going to add an extra 1. So I have 3 ones, 4 ones, plus that extra 1 that came from those 12 tenths. So I've got 8.25. So anyways, I hope that helps. I really appreciate it, and we'll keep going. Thank you so much.